Today we will go to the week 6 sampling and sampling distribution part 1. I'm the instructor Chong Guang Ho. I'm from the Kunshan University. This course is the master course. The course name is the quantitative research method. So today the topic we will cover the simple random sampling, and the second one, point estimation, and also we will introduction to the sampling distribution. Okay, so let's talk about the sample and population, and the basic is the element, and the definition of element is the entity of which data are collected. So you when you do the survey, and you prepare the questionnaire, the respondent can fill out this is the sample, and also we can call the element. Okay. A population is a collection of all the elements of interest. Population is the mean is the total. If you research with the total number, okay. A sample is the subset of population, because when you do the questionnaire, it is the survey, and you don't have time to do the everyone. So maybe we choose the subset of the population. We call the sample. Okay, so the sample population is the population from which the sample is drawn, and a frame, a list of the element the sample will be selected from. Okay. So why we select a sample? The reason is to collect data to answer research questions about the population, and the sample result provide only estimate of the value of the population characteristic. Okay, the reason is simple. The sample contain only a portion of the population. With the proper sampling method, the sample result can provide good estimate of the population characteristic. So the sample is the subset of the population. So you can, if you do the research, you do you want to collect the data for the high school student, maybe you focus on maybe in some area, the high school, and you can say the population, maybe you can say, oh, the population maybe in Taiwan, all public school, but in the sample maybe you choose in Tainan. Also, this is the same idea, because you don't have time to collect everything, and sometimes maybe some respondents, they don't want to fill out the questionnaire. Okay, so we have the two population, is the finite and the infinite population. Okay. So in the research, you need to see the real world, and maybe the good fit, moderate fit, and the poor fit. So you must be careful. Sometimes you choose the sample. Why you need to how to select the sample is very important. Sometimes maybe you do the random, and also maybe you select some sample. You must be careful what kind of method you select. So we will talk about this later. And the first one, we need to know the definition of population. Look, the collection of unit, be people, plant, city, suicidal author, to which we want to generate a set of finding or statistical model. Also the sample, a smaller and the collection of units from the population used to determine truth about the population. So this is we just talked about in the first slide, element in the entity of which data are collected. And the population is a collection of all the elements of interest. A sample is a subset of the population. So I think maybe you are much clear to what's the difference, the population and the sample. Okay, I give you the two examples. Okay, first one, member of political party in Texas will consider support a particular candidate for election to the United States Senate, and the party leader want to estimate the proportion of registered voters in the state favoring the candidate. A sample with 400 registered voters in Texas was selected, and 130 of the 400 voters indicate a preference for the candidate. Let's estimate of the proportion of the population of registered voters favor the candidate is the 130 is multiplied by 400. The number is 0.4. Okay. Divide by 400. Okay. So you see the sample is the 400, and the 130 is the preference, is they favor the candidate. Okay. So this 400 and the 130, this is the sample, not population. Okay. And the second one, a tire manufacturer is considered produce a new tire designed to provide an increase in mileage over the firm's current line of tires. To estimate the mean useful life of new tire, the manufacturer produced a sample of the 120 tires for testing, and the test result provide a sample mean of 66,500 miles. Hence, estimate of mean useful life for the population of new tire is the 36,500 miles. Okay. So you see the 120. This is the sample for test. Okay. And the sample mean is the average. They are 36,500 miles. So you can see you just choose the sample to test the tire. Okay. Okay. So when you choose the sample and the research must have the error. So you can see the formula, the only equation where you will ever need. Okay, so you can see the model. This is the real situation, and this is your model, and you can see it must have the error. Okay. Okay, so a sample mean provide an estimate of population mean, and a sample proportion provide an estimate of population proportion. With estimate such as this, some estimation error can be expected. The chapter provide the basis determine how large the error might be. Okay, we will talk about this in the following chapter. Okay. Okay, so let's talk about select a sample. We have the two kind of population. One is finite and in the infinite population. And first we talk about the sampling from a finite population. Finite population are often defined by these such as organization membership roster and the credit card account number and the inventory plus number. This is the in the finite. Now infinite, okay, we can count the total number. Okay. Okay, so this you can see a sample random sample of size n from a finite population. The population the number is the n, and the random sample is the small n. The sample select such a possible sample size n have the same probability of being selected. Okay. Okay, so let's talk about the finite population. Replacing each sample element before select subsequent element is called sampling with replacement. An element can appear in the same more than once. Sampling without replacement is the procedure used most often. Okay. Okay. So in large sampling project, computer-generated random numbers are often used to automate the sample selection process. So if we do the finite, maybe we can use the computer to select the sample. Okay. Okay. And this is the example in today's course. The director of the electronic association sampling problem. Okay, so the question is the director personnel for electronic association incorporation have been assigned the task of developing a profile of the company to 2,500 manager, and the characteristic to be identified include the mean and annual salary for the manager and the proportion of the manager have completed the company managing training program. Okay, so also I provide you the SPSS data. You can. Okay, so this example we do the practice for this chapter, and also I give you the file. You can check your folder, and the week 6 you have the eai.sav, this SPSS file you can open, and you can see in this file we have the two variables. One is the annual salary. This about about 25,000 manager, and the training program is did they join? They didn't finish. Did they finish the program? So you can see they have two variables, and the first one and the second one variable. Okay. So let's go to the slide to talk about the question. So the question is the characteristic to be identified include the mean annual salary for the manager, and the proportion have the complete. Okay, so let's go to the next slide. Okay. Okay. So we can see the question first. Using the 2,500 manager as the proportion for the study, we can find the annual salary and the training program status for each individual by referring to the firm personal record. The dataset contains this information for the 2,500 manager in the population in the file name EAI. I already talked about the EAI, this SPSS file. We compute the population mean and the population standard deviation for the salary. So let's go to the SPSS. So did you remember how to run the mean and mode and the like the median. So let's review, and you can go to the analyze and the frequency. Okay, so you choose this one and the training program. Okay, and the status. So you can see the mean, median, mode. Okay, so today we will do the like we want to have the standard deviation and the mean. Okay, so we choose the standard deviation and also maybe minima maxima. Okay, and maybe mean. Okay, so continue. Okay, so you can see the output. Okay, so you can see the first table. This we have the 2500 manager, and the can see the mean. We can see the is 51,800. Okay, this the annual salary, the mean average. Okay, and the standard deviation, you can see the is 4,000. You can see the is 4,000. So this is the, you can see the this is the salary. Okay. Okay, so this is the very long table because we have the 2500 manager. Okay, and the training program he have the 5000. They finish the program, and had 1000 didn't finish. Okay, so in SPS you don't need to calculate by hand, so it is very convenient. And in here maybe we can see the some formula, so you just need to know the you don't need to calculate this. So because the course is the statistic, maybe you have already have read some statistics book, and they, because statistics is the math, so he include a lot of the like the formula, and maybe they need to have a lot of the like some definition you need to. So in SPS you don't need to know the formula. Okay, so we already get this number in the SPSS. So the mean is the 51,800, and the published standard deviation, this is the data, is the 4,000. Okay, so the data for the training program status show the 150 of 2500 manager complete the training program. So you can see our output. You can see the list. You can see. Okay, this is the finish is the 60, about the 60%, and unfinished is the 40%. Okay. So numerical characteristics of the population are called parameters. And the let P denote the proportion of the population they complete the training program. We see the P is the 60%. So they say this is the proportion. Okay. And the population mean annually, this is the standard deviation. Okay. So we finish this section, and the next. Okay, so let's talk about the infinite population. Sometimes we want to select a sample, but find it's impossible. So obtain a list of elements in the population. So we cannot construct a frame for the population. So we cannot use the random number select procedure. So maybe in the sometimes we maybe we select by by ourselves. So sometimes it's not difficult to use the random number. Okay. So the population are often generated by an ongoing process where there is no upper limit on the number of units they can be generated. Okay, this is the infinite population. And is that sense some example? Transaction occur a bank because the everyday is the process, so they don't have the finite population. And the telephone call arrive at telephone help desk is the unlimited. And the customer enter a store is the no finite population. It may be every day they change. Okay, so the button, this is the example. McDonald's, the Facebook restaurant leader, implement a random sampling procedure for this situation. The sampling procedure are based on the fact that some customer present discount coupon. Whenever a customer present the discount coupon, the next customer served was asked to complete a customer profile questionnaire. Because a right customer present discount coupon randomly, independently of other customers, the sampling procedure ensure customer was selected independently. As a result, the sample satisfied the requirement of the random sample for the infinite population. Okay, so this is the Facebook restaurant example. So the McDonald's asked the customer, when they present the coupon, and the next customer will ask to complete the questionnaire. So this is the procedure. So sometimes you do the questionnaire, maybe you need to have the procedure how to select the sample. Okay, so the sampling from the infinite population. In case of the infinite, we must select random sample in order to make valid statistical inference about the population. So random, this is important. Okay. So this is some rule. A random sample size n from the infinite population is a sample select such as the following conditions are satisfied. First one, each element select comes from the same population, and the second one, each element is selected independently. Okay. Okay. So the next slide is we will talk about the point estimation, and then also we have the one example, and after finish the example, you will understand and clearly. Okay, so let's the same question about before we do this practice. A simple random sample of 30 manager and the corresponding data on annual salary and the management training program participation are shown in the table. You can see the table in the next slide. Okay. We have the 30 EI manager. They select from the 2500. This 2500 manager. Okay. And the notion X1, X2, and we denote annual salary the first manager in the sample and the annual salary for the second manager. You can see the S1, S2, S3, S4. This is we have the 30 manager in this company, the EI this company. Okay. And the participants in the management training program indicate by yes in the management training program column. Okay, so you can see that yes is the already finished the training program, and the no is didn't finish. Okay. Okay, so this slide we will practice the sample statistic. Okay, to estimate the value of population parameter, we compute a corresponding characteristic of the sample, referred to as a sample statistic. For example, to estimate the population mean mu and the population standard deviation delta for the annual salary or EAI manager, we use the data in the table, the following table, to calculate the corresponding sample statistic, the sample mean and the sample standard deviation, and use the formula. This is we already give provide you in the previous chapter. So you can see the sample mean is the sigma is xi. This is the total the salary, and is divided by n. This is the number of the manager. So this number is we choose the 30, and the total this is we add the all salary, annual salary. Okay, 30 manager. Okay, and the sample standard deviation, this is square root, and you can see the n subtract 1, so you can see the 30 subtract 1 is the 29, and you can see the sigma xi subtract sample mean and the square. Okay, so you can see the number is the standard deviation, the 3348. Okay, so we can correct if we put in the SPSS. We can correct this. We can do in the SPSS program. Okay, so here you just not need to remember this kind of formula. We can do in the sampling. Okay. The next slide is the talk about the proportion. Okay, sample proportion. So 30 and 90 is the finish the training program. So this is the 33%. Okay, percent finish the program. Okay. And we can call 37% didn't finish the program. Okay, so the next slide we will talk about the point estimation. So we already used the formula. We just give you the brief definition. Point estimation is the form of statistical inference. A point estimation, we use the data from the sample to compute a value, a sample statistic. They serve as an estimate of the population parameter. We refer to X. This is the mean. You can see the point estimate of the population mean. Okay, mu. Okay, call it mu. And the S is the point estimate of the population standard deviation, the data. Okay. And the P is the point estimate of population proportion P. Okay. Okay. So next, this is the example with the same EAI this program. Okay. Okay. So the next slide we will have we have the two population, is the target population and the sample population. What's the target population? The definition in the target population is the population we want to make inference about. So maybe in your research you want to focus on like a social network, some website. So this is the target population. And the sampling population is the population from the sample is actually taken. So this, whenever a sample is used to make inference about the population, we should make sure the target population and the sample are in close agreement. Okay. So here we just we were already talk about the population mean mu and the population standard deviation, the delta, and the population proportion p. This okay. And the sampling error. We before we talk about the research, in real situation and you do the research between them, they must have an error. And okay, so first one, when the expected value of point estimate is equal to proportion parameter, the point estimate is said to be unbiased, and the absolute value of the difference between the unbiased point estimate and the corresponding population parameter is called the sampling error. And sampling error is the result using subset of the population and not the entire population. And the statistical method can be used to make probability statement about the size of the sampling error. Okay. So we will talk about like the how to do like the when you do the research, maybe you need to test the reliability and maybe this kind of variability, this kind of bias test. Okay. And the sampling error, this is the sample mean, is the real, and the standard deviation and the proportion. Okay. Okay, so let's talk about the sampling distribution of X. And this diagram is the process of the statistical inference. And the first one, we choose the population mean. It determines. And you see the left side, a sample random sample is of n element is selected from the population. And you can see the sample data provide a value for the sample mean. And the left side, you can see the value of the sample mean is used to make inference about the value of mu. Okay. And this is the population mean is the come from. Okay. Okay. So the sample mean is the point estimate of the population mean mu, and the sample population is the point estimate of the population proportion p. Okay. Oh, okay. So let's go to the next slide. Okay. So the sampling distribution of the X is the probability distribution of the all possible value of the sample means, and this is the expected value. Expected value is the mu. Okay, mu is the population mean. Okay, when the expected value of the point estimate is equal to the population of parameter, we say the point estimate is unbiased. Okay, bias is near to the same, so this is the value, and the mu is the same. Okay. It's unbiased. Okay, so the next slide, we just go through the notation. Okay, notation for the standard deviation of the. So you can see the delta x is the standard deviation of the x, the sample x. Okay, and the mu, the delta is the standard deviation of the population, and the n is the sample size, and the bigger n is the population size. A capital N is the population size. Okay. Okay. So this is the standard deviation. This is the formula. So you can see the finite population. In finite population, is a little bit different. little bit different. Okay. A finite population is treated as being infinite if n divided by the capital N less than the 0.05. Okay. And the square root capital N minus N is divided by A, capital N minus 1 is the finite population correlation factor. Okay. The delta X is referred to the standard error of the mean. Okay. Okay, so let's go to the next slide. When the population has normal distribution, the sample distribution of the X is the normally distributed for any sample size normal distribution. Okay. In more applications, the sample distribution X can be appropriate by a normal distribution whenever the sample size is the 30 or more. Okay. In case where the population is highest, school and the outlier are present, sample size 50 may be needed. Okay. Okay, so let's continue to this slide, sample distribution of the X. And we see this table, population have normal distribution and the population don't have a normal distribution. So we have the way to do it. If the population is normal distribution, in many situations it's reasonable to assume that the population from which we are select a random sample have a normal or nearly normal distribution. When population have normal distribution, the sample distribution is normally distributed for any sample size. Okay, so another way, if population does not have a normal distribution, when the population from which we are select a random sample doesn't have a normal distribution, the central limit theory is helpful to identify the shape of sampling distribution. A statement of the central limit theory as is applied to the sampling distribution of X follows. So we will talk about the central limit theory in the later. Okay. Okay, so let's go to the next slide. So the sampling distribution of X can be used to provide probability information about how close the sample mean is to the population of mean mu. Okay, and we will talk about the central limit theory. Okay, when the population from which we are selecting a random sample doesn't have a normal distribution, the central limit theory is helpful to identify the shape of the sampling distribution X. So what's the central limit theory? We see in select random sample of size n from the population, the sampling distribution of the sample mean X can be approximated by the normal distribution as the sample size becomes large. Okay, so the sample becomes large, the sample distribution of sample mean can be approximated by a normal distribution. Okay, so let's go to the next example. So the EAI is the previous question. We computed the standard error or mean associated with a random sample with a 30 EAI manager. Okay, so this is we can calculate the standard error. Okay, so this equation is that we talked about before. Okay. So you can see this shape, sample distribution of X for mean and annual salary. Okay, so you can see this middle one is the 51,800. Okay, and the sample distribution of X, and this is the we call the standard error. Okay, standard error. This one standard error. And another example is if X is 52,300, and we can calculate this D. Okay, calculate D value is upper M, this D value. Okay. Okay, so you can see this. We have this the probability. Okay. Another example is the standard error. Okay. So we choose the sample size. We increase. We saw the first question. We just select the 30, and now we become the 100, and you can see the standard error is 400. Okay, and the same D value. Okay, and we can see the shape is changed. You see the black is when sample size is 30, and the blue one is sample size become the 100. Okay. And the middle one is the same, 51,800. Okay. Okay. Okay, so let's talk about this one. Make inference about the population, and the population with the proportion is P. We want to calculate this one. A simple random sample n element is selected from the population, and become the same sample data provide a value for the sample population P, and the value of P is used to make inference about the value P. So we can get the population P. Okay, and you can see the expected value of P. P is the population. Okay, so this is the formula. We calculate standard deviation. This is the data, and the standard deviation of finite population, and this is the infinite population, first one. Okay, and this is you have the two conditions. If the sample distribution can be approximated by a normal distribution, when the sample size is large enough to satisfy two conditions, it's n multiplied by P larger than or equal to 5, and the n multiplied 1 subtract P larger than and equal 5. So this is when these conditions are satisfied, the probability distribution of X is in the sample population P equal X divided by N can be approached by the normal distribution, because N is the constant. Okay. Okay, so this is the example, and we can find the the sample size is large enough. Okay, so we can see the n multiplied by p is the 18 is larger than 5, and the n multiplied e subtract p is larger than 5. Okay, so we can see the 12 is larger than 5. Okay, so this is the normal distribution. Okay, so this is the example. Maybe you have time, you can calculate this one. Just show we have a very clear explanation. Okay. So other sampling method we can use stratified random sampling, cluster, and the systematic convenience judgment. Okay. Okay, so this is they have the different sampling, they have the advantage, disadvantage. So you can see, okay. So the final slide, you can have some recommendation is the recommended probability sampling method, like a simple random, stratified, cluster, and systematic be used. For this method, formulas are available for evaluate the goodness of the sample result in terms of the cloning of the result to the population parameter being estimate. Evaluation of the goodness cannot be made with non-probability, convenience or judgment sampling method. Okay, so this is our class, today class. So see you next week. Bye bye. So now we will do the SPSS. Okay, so let's go to the data. EAI this simple. So let's go to the analyze, and you see you can see have a lot of function, and you can see the basic statistic. Okay, so we can see the one sample normal. Okay, so you can click, and the annual salary, okay, and the criteria, okay, is 95%, and we just click OK. So you can see the mode is the 51,800. This, and you can see this is the middle one, and we can see the shape. Shape is you can see, because we are sample is the 2,500. Okay, so you can see the output. Okay, this is the probability. Okay, so this for this example. Okay.